Now we are solving equations, which just includes the operations that we've just been using. Whether it's addition or subtraction of fractions, multiplication, division, doesn't matter. We just need to solve for the unknown. And right here, doesn't look like any of these are too bad. Let's take a look at some. So right here, we want to get that x by itself. So we'll just, we just need to subtract that 5/4. But if I do it to one side, I've got to do it to the other side, okay? So yeah, there's a lot of rules at one time. But hopefully they're kind of manageable because we've done this before. So I'm going to drop this x. X equals, I got negative 1/3 minus 5/4. So I need common denominators. I'm going to use 12. So I'll multiply negative 1/3 by 4 and 4, and the 5/4 I'll multiply by 3 each. So this changes it to negative 4/12 minus 15/12, which when I combine, I got 12ths, but negative 4 minus 15 is negative 19. I'd call that good. That will do. Very similar to number 1. The only difference is that instead of subtracting, we're going to have to add this 2/3. So plus this 2/3 here. Again, we need that common denominator. We will drop the x. But right here, it looks like my common denominator, 16/24. So yeah, we'll just have to multiply the 8 and the 5 by 3, which is 15/24. So the 3 by 8 and the 2 by 8 as well. Add 16/24. And when we combine those, we get 24ths, but 15 plus 16 is 31. And I don't think that can be simplified. That's better. Okay. So that's good. So right here, the negative 7/5 x is not being added or subtracted to anything. So it's not like the previous two problems where we have to add or subtract anything. All I want to do is change that negative 7/5 x to a 1x. So how do I change negative 7/5 to a 1? Very good. We're going to divide this by negative 7/5. See what that does is it gives us a complex fraction, but it comes out as 1. Anything divided by itself is 1. But if I do it to one side, I got to do it to the other side as well. So I'm going to divide negative 35 by negative 7/5. But we'll change this to multiplication and flip the fraction to 5/7. Now I'm going to write this negative 35 as negative 35 over 1. And we can simplify this, but let's say that we didn't notice that we could. So we got the two negatives. That's going to change that to a positive. And so I'm going to take 35 and multiply it by 5, 175. Yeah, that seems right. And then 1 times 7 is 7. I'm sorry?
Oh, 7 goes into 175.
Yes. Yeah, we can divide that straight across. 175 divided by 7, bam, 25. And whether you have the 1 there or not, it's not important. What is important that you realize is that 1x or an x is 25. Now remember, this is one of those steps that everyone forgets, but in your calculator you could put this in negative 7/5 times 25 and just make sure that equals 35. And if you did that on a test, you could know for sure that your answer is correct. Let's do it. All right. So I got that x/5, and we're subtracting something from it. That's not good, and we don't want that. So we got to get rid of that 1/2 by adding 1/2. So I got 1 plus 1/2. Make that 1 over 1 so we can change it into, so that we have common denominators, which is 2. So I got 2 over 2 plus 1 over 2, which gives me 3 over 2. Because we had the halves. Again, this zeroes out, and I'm just left with that x over 5. This is a proportional relationship because we have two fractions that are equal. That doesn't matter really. If it helps you, you can write x over 5 as 1/5 x. But whether that's necessary or not, here's what I'm going to do. So I have this divide by 5 right here. I don't want divide by 5. I just want x, okay? So I'm going to use an inverse operation of divide, which is multiply. And if I multiply this by 5, they'll cancel out. But if I do it to one side, I got to do it to the other side as well. So 3 times 5 is 15. 2 times 1 is 2. That would be my answer. Now, if we made this 1/5 x, it wouldn't matter if you divided by 1/5, because eventually you'd multiply it by 5 over 1. So it is the same thing, whether we use this inverse operation stuff that I did in green, or if you divide by the 1/5 the fraction. So I need to get rid of that 5, so I'll subtract 5 from both sides. And I'm left with that n/4. 4 minus 5 is -1. So again, inverse operation, divide by 4. So I'm going to multiply both sides by 4. Again, that'll cancel out the 4's. And I'm left with n equals -4. Bam. So again, the objective is to get the b's by themselves, and I got 2 b's. So I can't have that plus 9/5. I got to subtract 9/5. It was very generous of them. They gave us common denominators. So I got -11 minus 9, which is -20. And those are fifths. -20 divided by 5 is -4. So this one comes out really nice. 2 times b. Again, this is an inverse operation thing too, which gives us the 1b. Right? The 2's cancel out. It was multiplication. We divided. b equals -2. 12 is an interesting one because we already have denominators of 7. So if I use that inverse operation stuff and multiply both these by 7, it cancels out these 7's, but it cancels out these ones as well. And we're just left with b equals -12. So that one came out pretty convenient, which won't always happen, but every once in a while it does. So this one has the x on the other side of the equal sign. Hopefully that's not too big of a problem. Again, we want the x fifths, that's fine, but we don't want the -6. So we'll add 6 to both sides. -8 plus 6 is -2. Now to get rid of that 5, again, inverse operation, I'll multiply both sides by 5. They cancel. I got x equals 5 times -2. What the heck? I need more sleep, man. -10. I'm sure you guys do too. I'm going to do this one a little bit different than dividing by 5/4. Now, again, you can, which still takes 2 steps. This way it takes 2 steps, but I'm going to use inverse operation stuff. So to get rid of that fourth, because we hate fractions, right? I'm going to get rid of that fourth by multiplying both sides by 4, and those 4's cancel out. So I'm left with that 5x equals -20 times 4 is -80. See right there, just by getting rid of that fraction, hopefully we can go into that 5x equals -80 with a little bit more confidence. That's 5 times x, so to get rid of it, I'll divide by 5. And that gives us 1x, which is what we want. -80 divided by 5, -16. Now again, what would have happened if you had divided both sides by 5/4 then? So this is 5/4 times x, so I'll divide it by 5/4 to make it a 1x, which is good, but I need to divide over here by 5/4 as well. Now again, it may help to make that -20 over 1, but I'll change this to multiplication. So now I have -20. Again, maybe it's over 1. And I can flip that fraction and be 4/5. Now when I multiply these, And again, whether you cross simplify now or later doesn't matter. We'll get a negative because I only got one. 20 times 4 is 80. 1 times 5 is 5. See how it kind of led us to the same value right there? And then this is something I could put into the calculator. Negative 80 divided by 5, negative 16. So it's the same either way. But again, it just matters on preference. You prefer to divide by the fraction or get rid of the fraction off the bat. So